Let's talk about VPC now. Okay, so VPC or virtual private cloud is the networking layer or is a network service in AWS. Why do we need this service? Let's understand it. Okay, so let's suppose this is your AWS data center, right? In this data center, we have multiple racks in which servers are kept. These are multiple racks. Right? And in these racks, we are provisioning virtual machines. I mean, this rack says hardware, compute, storage, and we are provisioning our EC2 instances. So in this rack, on this hardware, there are 3 EC2 instances, 3 virtual machines, and they all belong to 3 different customers. Customer A, customer B, and customer C. Since all of them are part of the same hardware, there is a high probability that when customer A connects to his instance, he may end up connecting to the someone else's instance or this instance. And same is the case with customer B and C. There's a high probability. And if that happens, then there is a data security issues. There's a data breach because there is a high probability that these 3 customers are competitors. One is Flipkart, the other is Amazon, and the other is, let's say, any other company, Misho, which is gaining popularity these days. So these 3 are competitors to each other, and if they happen to see one another's data, then it diminishes the purpose. There is no point of going in public cloud because security loophole is there. So in order to avoid it, how does AWS differentiate resources of customers from one another? How is AWS doing it? What process AWS is following is the layer, is an isolation layer that you will provision. So that isolation layer is known as virtual private cloud. This is the isolation layer that they create. And in this isolation layer, they will make sure that one customer cannot see the resources of other customer. Isolation layer or a gate or let's say a perimeter network, whatever you want to call it. So AWS VPC basically gives you the capability, virtual private cloud gives you the capability to launch AWS resources into a virtual network. So you can launch resources into a virtual network, and this virtual network closely resembles a traditional network that you would operate in your own data center. So let's say you are not in AWS, you are in your, you are in a physical on-premise data center. In a physical on-premise data center also, you have some sort of restrictions. So for example, if you have a physical on-premise data center, in that data center also, let's say your company has a data center. That data center has a concept of VLAN. First of all, do you understand what a LAN is, guys? What does a LAN stands for?
Local area network.
I will share this notepad, with you at the end of the training so that you can also refer to it because this notepad has all the working that we are doing. So AWS, okay. So in a local data center, so first of all, LAN stands for local area network. What does a local area network means, guys? What do you mean by a local area network? Okay, before that, what is a network? Why do we need a network? What do you mean by a network? Basics are very important in life, fundamental. That's the fundamental of anything. If you do not understand the basics, and this applies to everywhere in your life, be it technology, be it personal life or professional life, if you don't understand the basics, it is very difficult for you to grow in your life, to grow in your personal and professional life. So basics are very important. Before you understand what a local area network is, you need to know what a network is. Before you understand what a network in cloud is, you need to understand what a network in on-premises data center is. Then only you can compare and correlate it with cloud. So guys,
A
what do you
network is a collection of computers.
okay? So network is a collection of computers. Why do we create a collection of computers?
To share information.
Okay, great. So collection of, instead of computers, I can write networking devices because that would include other things as well. Networking services or devices, and the example is a computer or laptop, right? So collection of networking services or computer. And why? Use case. What is the use case? To share information, right? To share or to exchange information. Is that okay? Is this definition making sense, guys?
Yes, sir.
Okay. Now let's talk about what is a local area network. Now, can somebody tell me what is a local area network?
To share information within a range, within a building.
Within a building, right? Because see, when you want to create a collection of computers, there has to be a boundary to this collection, right? When you want to share information, there has to be a limit that up to what extent you will share the information. So local area network is nothing but a boundary, and that boundary is within a building, within the building or within an office. So you are creating a local area network in your office, and only the computers inside your office can be added to that network. Is that making sense? For example, if I have two buildings, let's say in Bangalore IT Park, there are two buildings. One building is hosting Genpact, the other building is hosting Accenture. Can we create a local area network which both Accenture and Genpact can use together, and they can put their systems into it, computers into it?
Yes, sir.
No, this is not done. We cannot do that. I'm saying we can do it. We can create a network and ask Genpact and Accenture to actually add their systems to that network, but they will say no. They are two different companies. They may be competitor to each other. No. So always remember, when you create a local area network, it is always meant for a company or an office. You cannot span it across multiple companies. Okay. So typically LAN means a network which is limited to a building or an office. That is LAN. Then after LAN, we also have another type of network which is MAN. What is MAN, guys? What is MAN?
Metropolitan area network.
Metropolitan area network. How is MAN different from LAN? Just give me 1 minute, I'll be right. All right, guys, I'm back. All right, so we were talking about what is MAN, what is Metropolitan Area Network, how it is different from LAN.
It is the larger than the LAN.
Okay,
It connects the two computers or more within the two cities.
two cities. Okay,
Two different.
let's say any network which is spread across multiple buildings or cities, right? That's bad. Is there any other type of network other than this?
Yes, sir.
What is?
WAN.
Wide area network.
Okay,
W-
WAN,
WAN.
wide area network. How is it different from LAN and WAN? What is the difference between MAN and WAN?
Extended the over geographical area more than MAN.
Can I say this across two countries or across multiple countries?
Yes, sir.
Okay, so that's LAN, MAN, and WAN. Let's focus on LAN now. So let's say you are creating a network in your office. Now, in your office, when you are building a network, you already know that in your office there are different departments, right? You have finance, you have HR, you have admin, you have operations, and other departments. There are multiple departments in your office, and all of these departments needs connectivity, needs network to communicate and exchange information, right? However, these departments need some additional capabilities. For example, when you create a network, you also want to secure the network and ensure productivity. So how do you secure the network? For example, operations, the actual team which brings bread and butter to, to the company, you want to make sure that people who are in operations, they are not wasting their time in browsing social networking sites or sharing company specific information via email to somebody else. I'm just taking some example. However, your HR team should get access to the sites because they need to go on LinkedIn and source people, find employees, I would say find talent. So HR team should have access to social networking sites or professional networking sites. HR team should also have access to emails so that they can send emails to employees, to candidates. Similarly, admin needs some special access and finance needs some special access. And these department also needs to communicate with each other. Finance needs to talk to HR, admin needs to talk to HR, finance, operations also needs to talk to HR. Let's say operations team, there is an employee who wants to get the pay slips of the last 3 months, or who wants to query something related to medical insurance, right? So they also need to communicate. What I'm trying to say here is that there could be n number of departments in your office and they may have some specific networking requirements. So in order to address these requirements and secure the network and ensure productivity, we actually use the concept of VLAN, which is known as virtual LAN, virtual local area network. So we create a LAN and then we break that LAN into multiple VLANs. And we allocate VLAN to a specific department, and then we put restrictions into the VLAN that computers in this VLAN should be able to do this or that, or should not be able to do this and that. Right? That's what we do. Is it making sense, guys? Yes, no, maybe?
Yes.
In fact, in your office, I'm sorry, in your college, if you had a computer lab, you must have a couple of systems in the lab. Some systems had certain restrictions, but then there are lab administrator or the lab in charge who also has a system. That person has no restriction on his system, but on the actual systems in the lab, you may have some restrictions. Maybe Facebook was not allowed, emails were not allowed, or other websites were not allowed. But on the admin system, there was no restriction. But both are part of the same network because your admin system and your lab systems, and in fact, the other computers which are there in the college in various rooms, they're part of the same network. But still they have different capabilities. Why? Because of this VLAN concept. Because what your college networking team has done, they have created multiple VLANs and they have allocated VLANs to the system. They have created system from those VLANs so that they get the appropriate rights. Now, when I say LAN and VLAN, it basically talks about an address space, IP address. An IP address. You understand what an IP address, guys?
Okay, protocol.
Yeah, but why do we use an IP address? So here we said that we want to share information, or these computers needs to talk to each other. How do they talk to each other? They don't know each other. How do they recognize? In the internet terminology, every system needs an IP address. In fact, your laptop has an IP address, right? So IP address is like an address or an identity of that system. Nobody understands that you have a Dell computer which has i5 processor, 8th generation, 8 GB RAM, 256 GB or 512 GB SSD or HDD. Nobody bothers about it. If somebody needs to connect to your computer, all they need to know is the IP address of your computer so that they can connect to it, right? So we have two types of IP address. We have public IP address and private IP address. Public IP address is an address which is routable over the internet. It means that if your system has a public IP address, then anyone can access your system over the internet. You can host applications in your system and publish them to the internet. That's public IP address. Private IP address basically means an IP address which is local to yourself, which is private, which is not routable over the internet. So when you create LAN or VLAN, you basically use a private IP address range so that only your company will have, your company and the people in your company and the computers within your company can communicate with each other. They're not talking to the computers which are hosted in other building which belongs to other company. That's private IP address. Now private IP address has classes. So there are classes of IP address: class A, class B, class C, class D, class E, and we primarily use first three classes A, B, and C. And every class has a private IP address range. So class A has a range of 10, 10.0.0.1, 0. Class B has 172.16. Class C has 192.168. So they have range. So typically when we create a network, we take an address space and we break that address space into multiple smaller address spaces, which are known as VLAN. And same is the concept in AWS. In AWS, we will create a VPC, right? And we will need an address space for the VPC, which is, let's say, 192.168.1.0/24/24 is the CIDR block. It basically says that in this address space, there are 256 IP addresses available. That's what. Now this is a bit, overhead transmission for you. I can understand, guys, because you are not coming from networking background, but we cannot go into the detail of networking. Otherwise, the overall objective will change of this training. We want to stick to AWS. So a couple of things you can just remember for the sake, and then you can study in your spare time about basics of networking. People who are from electronics and electrical engineering, they may not have studied, networking. They may not be aware of these concepts. So what I will do, I will share a slide, I will share a presentation with you, which has all of these basic information, which has a couple of slides which will introduce basics of networking. What is LAN, WAN, MAN, IP address, private, public, ranges, subnet mask, and everything. So you can go through it. That will give you some information. Now, for the purpose of this training, let's just stick to these topics. So what we need to do, what we are going to do today, we will create a VPC in AWS, and we will use this address space in the VPC. Then we also need VLANs. So VPC is equivalent to LAN. Then we need to break that VPC into multiple VLANs so that we can put systems. We can put computers into that VLAN. So we also need subnet. So our VPC range is 192.168.1.0/24, and we'll create a subnet in that VPC, and the range for the subnet is 192.168.1.0/27. Why we are taking 27? 27 gives me 32 IP addresses. So I'm taking 27. So you don't need to get into the detail of it. Just remember these two settings. Typically, AWS has a default VPC also that you can leverage. But I want you to create something by yourself so that you understand the creation process. So that's on the VPCs and subnet. Now let's go back to the theory. So theory says that you create VPC in your AWS account, and then you provision computers or EC2 instances into that VPC. So VPC is needed to provision services, and your VPC is separate from others' VPC, other companies' VPC. So on the same hardware, there could be 1,000 computers running, but all of those computers will belong to a VPC, which belongs to a company. So that's how AWS is making sure that you are not able to see others' computer, right? So you can launch AWS resources in a virtual network. Now, AWS VPC is the networking layer for Amazon EC2. AWS VPC is a virtual network dedicated to your account. So it is dedicated to your AWS account. No other customer will have access to it. And it is a logical isolation. See, it is logically isolated from other virtual networks in the AWS cloud. So every customer has a VPC, which is isolated from others' VPC. And that's the reason you're not able to see what other customers are hosting. So it is a public cloud. Everyone has access to it. But every customer has its own identity. You can launch your AWS resources such as EC2 instances into VPC. You can specify an IP address range for the VPC, which is what we have just written. We will use this IP address range. Add subnets. So we will add one subnet, which is this subnet. And you can associate security group. I'll talk about what a security group and route table is. Then you can optionally associate an IPv6. IPv6 is the next level of IP addresses. IPv4 range is almost getting exhausted. So they have come up with another range, which is an hexadecimal IP address. A VPC spans all of the availability zones. I will say when you create VPC, you can create them in the availability zones. After you create VPC, you can add one or more subnets. There is no additional charge for using a VPC. Now, this is a great piece of information. AWS or Amazon does not charge you for creating VPCs. So you can create as many as VPCs, but when you provision or build or create an EC2 instance in your VPC, then you need to pay for that instance. So there are charges for some VPC components. I will say VPC also requires some additional services. There are charges for it. Okay, let's understand the building block here. Now we were talking about public and private subnet that you must have, seen in the video. What is the difference between public and private subnet? As the name suggests, I can create a public subnet and all the computers or EC2 instances or virtual machines in that subnet will have a public IP address so that they are available over the internet, or I can host applications on those instances which will be available over the internet to public. That's what public instance is. Then private subnet, any instance that I will provision in the private subnet will not be accessible over the internet. It will be internal to my network, right? Like database servers. I don't need to expose my database servers to internet, but web servers, yes, I need to expose them because users are connecting to the web servers. VPN only subnet, we can also create subnet and we can put resources into that subnet which are only accessible over the VPN. So example, when your company has an AWS account and when they are hosting some application in AWS, you as an employee of the company sitting at home also needs to connect to those applications. So we can put those application resources into VPN subnet and only they will be available over the VPN. So this is the explanation. Now, what is a route table, internet gateway? So we'll talk about it. So route table basically means route table is nothing but a path or a table which maintains route, which basically has information that if A is communicating with B, then what route it should take, what path it should take. If you want to go from Delhi to Bangalore, how many options are available? You can go via road, you can go via air, you can go via flight, you can also catch a train, you can take a train also. So those are the options. Which one is the convenient option or which is the most fastest option? Flight, you can take a flight and you can reach from Delhi to Bangalore in 2 hours. Train will take 16 to 20 hours. And by road, it will take maybe a couple of days, maybe 1 or 2 days. So which is the fastest path to reach Bangalore from Delhi, guys? Which is the fastest path?
Flight.
Flight. That's what route table does. So route table has all the information about the path. Route table knows what is my source, what is my destination, and route table knows which is the fastest path to reach my destination. That's what route table does. So when a system, when your computer, let's say computer name is A, connects with computer B, a route table will know how this connection will happen. That's what route table does. So that's exactly what is written here. It is used to determine where network traffic is directed, right? And it controls the routing and it will use the path. Then comes internet gateway. Now, by default, when you create a VPC in your AWS account, it does not have access to the internet. By default, it is internal to you. But if you want your VPC to be, if you want the resources in the VPC to have the capability to access resources from the internet, let's say you provision a virtual machine in your VPC. Now you want to access internet on that virtual machine. You want to access Facebook, Yahoo, email, and whatnot. Then you will need to use internet gateway. So internet gateway is a service which gives ability to resources inside the VPC to communicate with the internet. So into your VPC and the internet. That's what internet gateway does. Then we have net instance. We typically use net instance when the private subnet resources needs connectivity to the internet. By default, the public subnet resources, when I say resources, I mean virtual machines or EC2 instances. So the virtual machines that you provision in public subnet, they can connect to internet using the internet gateway. But the private subnet virtual machines use a net gateway to connect to the internet. Now, what a security group is? Security group is like a gatekeeper. Any machine that you create in AWS, for example, this is your EC2 instance that you have created inside a subnet, which is part of a VPC. and that VPC is part of a AWS account, right? And this is your virtual machine. Now somebody is trying to connect to this virtual machine. So this virtual machine also has a security group. That security group is nothing but a firewall, a network firewall. This is the network firewall. And this network firewall is before the VM. Now, this network firewall will inspect all the incoming traffic. And if there is a rule that allows this traffic, then only it will go forward. So when you communicate over the internet, you basically communicate on port. So let's say there's a traffic which is coming on port 80 on this VM. The traffic will go, it will first has to go through the firewall, which is the security group, virtual firewall. The virtual firewall will see whether I have a rule that allows traffic to this VM on port 80. If there's a rule that allows traffic to this VM on port 80, it will allow that traffic to go through. Otherwise, it will drop that packet then and there. It will stop it, drop it. That's what security group is. So these are the VPC components basically, and they collectively constitute a VPC or constitute a network in your Amazon cloud. And these components are responsible for security and management and governance also. This is how it looks like basically. So if you can see here, let's try and understand this image. So this outer boundary is your AWS account. This one, that's your AWS account. The inner boundary, this one is your VPC. This box is your VPC. So this is your VPC actually. And your VPC address space is this 10.0.0.0. This is your VPC address space. Then in your VPC, there are two subnets. These are subnets. This one is public subnet, and this one is private subnet. If you look carefully in the public subnet, you are keeping your web servers, because web servers needs to be accessible over the internet. They need internet connectivity. So you're putting all your web servers in public subnet, and you're putting all your databases in private subnet, because databases do not need to connect to the internet. They contain the actual data of your application, and you need to protect them. You need to secure them. So you're putting them in the private subnet. Okay. You've also used the concept of availability zone. Your VPC is part of availability zone A, right? Then comes the gateway. So you have a net gateway here. This net gateway is basically, if these database servers needs connectivity to the internet, they will actually use this net gateway to connect to the internet. Then you have a route table here. This route table has the path. So if these database servers needs to connect to web servers, or if web servers needs to connect to database servers, or if they need to go to the internet, all the information is kept in this route table, all the information. So route table knows, okay, this database server 1.5, this one, because see, nobody understands the name. People, in internet, you understand the IP addresses. So communication happens through IP address. So if 10.0.1.5 is trying to connect to 10.0.0.7, then how it should connect? This information is available in route table. If 10.0.1.5 is trying to go to facebook.com, how it should go? This information is available in the route table. So route table has all the information. So route table has path to net gateway, to internet gateway, and to internal communication. That's what this image is talking about. This image is showing you a VPC. And after internet gateway, you have this is internet. This is internet basically. So if these machines needs to connect to the internet, they will first go to its route table, and from the route table, they will get a path to internet gateway or net gateway, and then they will connect to the internet. That's what this is, a simple reference architecture of an Amazon VPC. That's what VPC is all about. And this is what, which is part of your training. Your training does not have lab in the VPC, but I will still go ahead and do a lab so that you don't only understand it theoretically, you also see it happening in happening in reality, so that you retain this information for a longer duration, right? This is another AWS basic architecture. Here you see a basic architecture, simple architecture. This is your AWS account. This is your VPC. In your VPC, you have two subnets, and both the subnets, the public subnet has a web server, private subnet has some machines. They both have a route table, and route table has part to net instance and internet gateway. These are the users who are connecting from the internet. So all the information is there. Okay, now we will do a hands-on lab, and this slide has all the information. So typically we do this lab for people who have good experience in networking, who have good experience with other cloud, and they are learning AWS, or they are learning AWS from scratch but have good experience on networking. Since you guys do not have that level of experience, I'll try and simplify this lab for you. This is a bit difficult lab, but I'll try and simplify it for you so that you understand it. So let's do a lab here for VPC. I'll simplify it for you so that you understand it. Okay, create a VPC name, address space, tenancy, default, edit the host name, create subnet. We'll only create one subnet, not two subnets, to make it simple for you. So create a subnet. And we'll create a public subnet so that our virtual machine that we create in that subnet is able to access the internet. Create route table each. Create route table and associate it with public subnet. Create an internet gateway and associate it with the VPC created in first step. Navigate to route table created for public subnet. Create a route for destination. This is not needed. This is step number 6. Step number 7.
11 also not needed.
8. Create an EC2 instance. 7 is not needed. Create your EC2 instance in public subnet using its public IP. That's it. This one is not needed. That's great. All right. So what we are going to do, guys, let's just see it once again. We are going to create a VPC. We'll give a name to the VPC. We'll select the address space. We'll select the tenancy. We'll do some settings. Then we'll create a subnet in the VPC. Then we'll create a route table, because as I said, without a route table, nobody will know where to go. So if you don't have a route table, you will be sitting in Delhi. You will know that you need to go Bangalore. You need to travel to Bangalore, but you will not know what are the ways to travel to Bangalore and which is the fastest way to reach Bangalore. That's what route table takes care of it. So we'll create a route table. Then we also create an internet gateway because we want our VMs to connect to the internet. An internet gateway is the service that gives the ability to a VPC to connect to the internet. Then we'll go to the route table and we'll create a path. I'll show you. Then we'll create an EC2 instance into a virtual machine, and we'll select a security group and we will connect to our virtual machine. So this is what we need to do, 8-step process. This is our VPC lab.
Sir, VBS not needed, huh?
Sorry?
VBS.
What is VPS?
Hard disk to create some data on that.
No, we will need it. That we will see. This is first we are focusing more on VPC. Once we create our EC2 instance, then I'll tell you how to add disk to it. Right?
Okay.
This
Okay.
is AWS VPC lab. Okay. I'll share this information in the chat window so that you can copy it on your system and keep it, because you will need to follow these steps. I've just put it. I hope everyone has received it. Did everyone receive it?
Yes, sir.
Yes, sir.
Okay, great. Now all of you put it into a Word document. Keep it like this so that you can refer to these steps while you are building your solution. Okay, I've kept it like this and your console as well. So that I have both the windows together. All right, let's do it. So let's click on VPC in the search bar. Please type VPC. And let's go to VPC Blade. This is the VPC Blade that we see. I'll be right back, guys. Just give me 2 minutes. Let's have similar screen on your laptop. On one screen you have your AWS account, AWS console, and on the other screen you have this Word document so that you can refer to it simultaneously. All right, guys, I'm back. Let me connect my PC. Am I audible?
Yes, sir, audible.
Yes, sir.
Yes, sir.
So let's do this exercise. So we are going to create a VPC. I'll also type the IP address here that you need to use. 192.168.1.0/24. That's what we need to use for VPC. And for subnet, we will use 192.168.1.0/27.
27.
Yep, that's what we need to use. So please make this, edit in your respective Word file. Okay, now let's do it. So on this page, do you all see Launch VPC Wizard option? Do you see Launch VPC Wizard?
Yes, sir.
Yes, sir.
Let's click on Launch VPC Wizard. When you click on Launch VPC Wizard, it opens a page that says Create VPC. Okay, now we will create VPC. So it says, do you want to create VPC or VPC in subnet? So we want to create a VPC in subnet both, right? So let's create a VPC. So we will select the option that says VPC subnet. Now we will type the name tag auto generation. So we'll type the name for the VPC. You will not type the name here. We will type it later on. So they have changed the option. I will say AWS is very dynamic or cloud is very dynamic. They keep on changing the option. They have made it more simpler for us now. So they have changed the UI. Let's do this. So we'll type the IP address v4 CIDR block. I will say address space. We'll type it here. You see 10 series, remove it. And type 192.168.1.0/24 here. Okay. Then comes tenancy. Tenancy will remain default. IPv6, no IPv6. We don't need any IPv6. So we'll keep it like this. And tenancy, we will remain default. Then comes availability zone. There are 3 availability zones. We can choose the first availability zone. Then comes number of public subnet. We'll select one. We'll select one public subnet. And then it comes customize public subnet CIDR block. We'll click on this. So number of public subnet, we'll select one, and then we'll click on this arrow. It will open a drop down and we'll put the public subnet CIDR block. So we'll type it 192.168.1.0/27. Okay, and we'll remove the other one, 10 series from there. Is it okay with everyone till now?
Yes, sir.
Okay. Then comes private subnet. We'll make it 0. I'm not going with private subnet, so we will not select anything. We'll just select the 0. Then comes net gateway.
Bro.
So we'll not select any net gateway. We'll keep none as checked. Then VPC endpoint, we'll keep none. Okay. Then comes DNS options. Enable DNS hostname, enable DNS resolution. We'll check both the boxes. So this is my first step. So I'm creating a VPC. I have put it the name, address space, tenancy is default, and I'm creating a public subnet. You can see it once again from the top. The name I'm selecting VPC subnet option. Then it says auto generate. Now I'll put the name of the VPC also. So I'll put the name as my VPC. Let's say all of you please select your name _ VPC. So Name of the VPC is your name underscore VPC. This is the address space of the VPC. We don't need IPv6. Tenancy is default. Availability zone is 1. Public subnet, you need 1 and you provide the address space for the public subnet. This other one field you will remain blank, the other box. Then private subnet 0, net gateway none, VPC endpoint none, and DNS options, both the options you need to select. Check the boxes. That's it. Now, whatever options you have selected here, you will also see them reflecting here. It is reflecting it here that this is your VPC. This is trying to create an image here. So this is the preview. So we'll just leave it. This is what we need to focus on. Is everyone done this till point? Then we will hit create. Is everyone done?
Sir, wait 1 minute.
Once again, you can see all the settings. Guys, quickly do it. All right. So once you are done with this, you need to click on create VPC. Now, when you hit on create VPC, it gives you an error. It says 192.168. Oh, I forgot 1 dot. After 1 and 0, I forgot to put dot. Now that is okay. Now I'll hit create VPC and see it is creating VPC. So you can see the workflow. All of these entries are getting created and they are created. Now my VPC is created. So what it has done, it has created a VPC. It has enabled the DNS hostname resolution. It has verified that the VPC is created. It has created one subnet. It has created internet gateway also. It has attached internet gateway to the VPC, which means now AWS is making my life more easier because I wanted to do this step, but it has already done it. See, I had this step, create an internet gateway, step number 4, create an internet gateway and associate it with the VPC created in step 1. This is already done. So I don't need to use step number 4. So AWS is making my life more easier with this new workflow that they have created for VPC, which is making it more easier to do. So this step, these two steps, create internet gateway and attach it to the VPC. Step number 4 is completed here. Then comes create a route table and associate it with public subnet. This part is also completed here. It has created a route table and it has associated the route table also. So which means my step number 3 and my step number 5 has already been taken care of. 3 and 5 is done, 4 is done. Step number 1 and 2 I have done. So we are good till step number 5, but we will need to validate it. So let's quickly validate it. So this is my VPC. Now, if you want to see your VPC on the same, let's say you are on the home page and you want to go back to your VPC console, all you need to do either type in the search bar VPC and click on it. It will take you to the VPC blade. There you can click on your VPC here. Under virtual private cloud, you can click on your VPC and it will populate all the VPCs which are there. So I've got 6 VPCs so far. Lavesh, sample VPC. This sample VPC, this is a default VPC which is already there, which I created. So forget about it. So I've got all of these VPCs. Now I'll click on my VPC. This is my VPC, right? This is the VPC that I have. Now on this VPC, I need to check a couple of things, right? So first I need to check if there is a route table on this VPC. First of all, I need to check if there's an internet gateway attached to this VPC. So I'll click on the VPC ID and here I will see everything. So let me first see if there's an internet gateway attached to it. I don't see it here. Okay, no worries. I can click on here. They have changed some options. I can click on internet gateways here. I just need to remember my VPC ID, last 3 digits. Let's say these are the last 4 digits, AD32. That's my VPC ID. Now I'll go to internet gateway. I have a couple of internet gateway and I'll see if they are attached to my VPC. Yes, I have this one. See, this internet gateway is attached to my VPC already. You can see VPC ID here, AD32. So this step is already done. So I'm good. I'm good with the 4th step, which is create an internet gateway and associated with the VPC. 4th step is completed. Let's say, then I'll say the route table, whether a route table is created and associated to the subnet. Now I'll go back to my VPC. I'll go to the right route table part. These are the route tables that I see. Yes, I can see a route table here, Raghuveer VPC route table. This is the route table, and I can click on this route table, which will open this at the bottom, and I can click on the route. So yes, I have a route. This is the route which is connecting to the internet gateway. So this step number 5 is also complete here, which they have already done, which is then I need to see this route table is associated to my subnet or not, my public subnet that I've created. So I'll click on subnet association. Yes, it is associated to the subnet.